Good afternoon to all the distinguished speakers.
Ma'am, you can
Good
start.
afternoon. Good afternoon to all the distinguished speakers, respected guests, and dear participants. It's a great pleasure to welcome you all to day 4 of this FDP program. Your presence today reflects a shared commitment to learning, collaboration, and academic excellence. We are especially honored to have eminent experts and scholars with us whose knowledge and experience will greatly enrich the discussions ahead. I extend a warm and heartfelt welcome to our speakers and sincere thanks to all the participants for taking their time to be part of this event. We look forward to an engaging and insightful session ahead. Once again, welcome everyone, and let us begin the proceedings on a positive and inspiring note. It's my pleasure to invite and introduce Dr. A. Saran Kumar, Assistant Professor at in the Department of Artificial Intelligence and Data Science at Coimbatore Institute of Technology, Coimbatore, as a speaker for our first session today. Dr. Saran Kumar holds a PhD in Information and Communication Engineering from PSG College of Technology. His academic journey spans information technology, computer science and engineering, and human resource management, thereby reflecting a rare blend of technical depth and leadership insight. With 8 years of teaching and research experience, he has made significant contributions to the academic community, including Scopus and SCI Index publications, multiple international conference presentations, and filed patents. He is also a strong advocate of continuous learning, having completed several courses through NPTEL and Coursera, and has successfully executed funded projects under the TNSCST scheme. We are confident that his expertise and perspective will add immense value to today's session. Please join me in warmly welcome Dr. A. Saran Kumar. Sir, please continue, sir. Sir, sir, please continue. Sir, am I audible? Am I audible, sir?
Madam, you are audible. I hope host till not yet joined, madam, or resource person. Let's
Okay, sir.
wait for the.
Then we all please wait till he joins and the session will be started.
Okay, madam.
Professor Saran has joined, so we can start now.
Sangeeta madam, Please continue the session, ma'am.
Okay, thank you, sir. Once again, it's my pleasure to welcome the speaker of the first session of day 4 of this program. Please join me in warmly welcome Dr. A. Saran Kumar. Sir, please continue, sir. Hello, sir.
Hello, ma'am.
Yes, sir. Sir, please continue, sir.
Okay, ma'am. Okay. Thank you. So, good afternoon, all. Is my screen is visible?
Yes, sir.
Yes,
Yes,
sir.
sir, visible.
Hello.
Sir, it's
Yes,
visible,
sir,
sir.
visible.
Okay, thank you. So, good afternoon, everyone. Thank you for a wonderful introduction. So, for today's topic, we have generative AI in industry automation and intelligent applications. So, I think for the past 2 days, you have an awareness about what is generative AI and under what applications you can go for using generative AI. So, all those things, I think you have an clear idea. So now we'll move to the today's section, that is Gen AI in industry. So how generative AI will be used in industry, we'll be seeing. So first we have a short introduction about generative AI. So as we know that generative AI is one of the fields of artificial intelligence, that is like ML, DL. Generative AI is one of the fields of AI where we can use generative AI to create images, text, audio, video, and what are the requirements user post we can get from the generative AI. So it is a branch of AI. And with advancement in AI, generative AI mostly rely on LLM and deep learning techniques. That is, we can create a large language model. Initially, in initial stage, we used to have a small language model. So we used to have a small language model. Nowadays, with the advancement of machine learning, deep learning, we always go for using this large language model. So large language model is nothing but a model that is trained on large amounts of data, where we can give a task to the model and we can make them to complete the task, or we can automate the task. Okay. So the model is trained on a large millions of amounts of data. So the name has been evolved as a large language models. So this generative AI is one of the applications of large language models where it will be learning from the vast amounts of data. That is, it will be learning from the large amounts of historical data, and it will be producing outputs based on the user query. And this generative AI always go for using neural networks to understand and replicate like a human creativity. That is, we have a multiple collections of neural network like artificial neural network, LSTM, RNN, deep neural networks. So this generative AI is built using the neural networks. So this neural networks, as it resembles a human brain, it thinks like a human and make solutions or predicts the output for the given inputs or for the task. So it can produce content that is often distinguishable. That is, with the use of generative AI, we can generate an output so that is most differentiable from the human outputs, or that will or we can get an exact output what the human think like that. That is an about generative AI. We have a introduction about what are the key technologies we can go. So now we have a basic idea about what are the key technologies we can go for using in generative AI. So first technology is transformer architecture. So one example for transformer architecture is so you already know about ChatGPT. So nowadays everyone is using ChatGPT, even the school students. They will be asking a query to a ChatGPT and they will be getting a results. So ChatGPT is one of the example of large language models, and this ChatGPT uses a transformer architecture. That is, it have a collection of multiple encoders and decoders. So whenever a query is posted or a prompt is given, the prompt will be processed with multiple layers of encoder and decoder and will be producing outputs. So this transform architecture is one of the example of GPT models or large language models. That is the first technology. Second technology is a diffusion model. So diffusion model, we have multiple diffusion models like DALI, stable diffusion, and we have one more diffusion model like LangChain. So all those are models or frameworks which will be used to build large language models. Next one is variational autoencoders. So it is an subtype of autoencoders where we'll be using this type of neural networks for generating text output data or text structure data. Next one is we'll be using GAN, that is generative adversarial networks. So this GAN, since variation encoders are used to generate a text output, this GAN will be used to generate an image output. So this is one of the key technologies. Next one is a reinforcement learning. So reinforcement learning will be used to generate an optimized output. That is, initially you will be given one prompt to an LLM. You will not be getting exact results what you are thinking for. At the time, what you will be doing is you will be revising the prompts or you will be optimizing the prompts to generate the output exactly requires. So that is about reinforcement learning. Next one is neural state transfer. So here what you will be doing is you will be combining the content and state for artistic creations. So where you will be combining the content generated by the LLMs and the style that is defined by the user to generate an exact output. So these are all the various key technologies we'll be using for generative AI. First one is transformers. Second one is diffusion models. Third one is variation autoencoders. Next one is GAN, that is generative adversarial networks. Next one is reinforcement learning. Next one is neural style transfer. So next we can see, before moving to the in-depth applications of generative AI in manufacturing, we can see about some of the use cases of generative AI. So common use cases. First one is content creation. So where you will be using an LLM or a large language model to generate a content in the form of articles, stories, poetry, scripts, or poems. That is the first use case. Second one is code generation. Under code generation, what we'll be doing is nowadays we are using a vibe coding, and then without coding, that is no coding, like that platform we are using, where we'll be asking LLM to generate a codes for a particular task or to generate a codes for a particular programming assignment. So that is about code generation. Next one is image and video generation. So where we'll be using an LLM or a generative AI model to generate an image or to generate an image for a particular text content or to edit the photos or to combine videos, we can go for using this image and video generation. Next one is conversational AI. So here we'll be using a generative AI to create a chatbots, visual assistants, or a language translation. For example, whenever you need to create a chatbot, for converting from one native language to a foreign language, you can go for using this generative AI. Next one is drug discovery. So we'll be generating new molecular interactions that may happen across multiple drugs by use of this GenAI models. Last one is text to speech and speech to text. So whenever you need to generate a textual output from the voice input, you can go for using this neural network models. So these are all the various use cases of generative AI. That is content creation, code generation, image and video generation, conversational AI, drug discovery, text to speech and speech to text. So these are all the various common use cases of generative AI. So next we move to how generative AI helps in manufacturing sector or manufacturing industry. So under manufacturing industry, generative AI will be helping in these subfields. So totally we have six subfields. First one is product design and development. So we'll be under this category, we'll be using generative AI for prototyping. That is, in order to make the prototypes of a particular model, we can go for using this generative AI to create an idea or to customize a particular product at a larger scale to reduce the cost or to optimize the cost. We can go for using the generative AI. So under product design and development, we'll be using generative, that is, the engineers will be using generative AI to optimize the product designs based on a particular material type or a weight and performance constraints, and also to innovate more ideas or to innovate or to redesign a new model and reducing the prototyping time and to make an efficient manufacturing solution, we can go for using the generative AI. Second one is customer service. So to make the corrections or the suggestions given by the customers for a particular product usage, we can go for the creation of chatbots or for a personalized interactions that is of 24 by 7 support so that uh, we can customize the product as per the user requirements, or we can incorporate what the user has been given as suggestions for a particular product. So in this case, generative AI will be largely used to design a chatbot or to design a web applications where the task of refining the product will be done automatically. Next one is marketing. So under marketing, we'll be getting a personalized advertisements or personalized product recommendations for all the customers based on the use of generative AI. So once a person logs to a particular website and he is looking for a particular product, they use on the models, that is deep neural network models, the customer will be keep on getting an advertisement or an information about the particular product in which the customer has been visited previously. So in this case, we can personalize the content display and we can provide a personalized content for a particular user in order to increase the sales of a particular product or in order to increase the revenue or target for a particular company. So in this case, we can go for using the generative AI. Next one is financial services. So to predict the fraud and to predict the risk or to reduce the customer churn, in this case we can go for using this neural network model. Whenever we are posting data to this neural network model, it will be identifying that which customer would be like to churn at a particular point of time based on the service buying behavior or based on the product usage. Next one is supply chain optimization. So under supply chain optimization, we can predict the demand for a particular product or to manage the inventory. The generative AI can be used. So the generative AI will be stimulating the product production workflows, and also it will be optimizing the staff scheduling and material flow, and it will be empowering the managers to produce a product that is of need of the heart and to increase the revenue for the manufacturer. So this generative AI can be used to increase the process efficiency so that the product can be reached to the shop from the manufacturing unit at a correct time, so that the cost can be so that the profit can be increased for the manufacturing company. So in this case, supply chain optimization has been used. Next one is we have one different application, that is quality control automation. So using Gen AI or generative AI, we can be used to capture the defects, that is minute defects that cannot be captured by the humans or naked eyes. So this, with the advent of this Gen AI models, that is deep learning models, we can predict, we can capture the defects, and we can increase the training. We can increase the training data sets for a particular model so that we can get a high accurate results, and we can reduce the defect in the product, and we can make the product to be of defectless. Next application is human resources. This generative AI can be used to train applications or to filter the applications based on the requirements as defined by the industry, and based on the requirements given by the people, that is based on the area of interest. This generative AI can be used to for human resource analysis. Next one is digital twin enhancement. So we can be used the digital generative AI to augment with the digital twins by generating a continuous data, and we can enable the real-time performance prediction, and we can optimize the system performance, and we can make an adaptive decision making, and also to increase the precision on the output of the manufacturing unit, we can go for using this generative AI. So these are all the various creative industries where generative AI is used as of now. Apart from the manufacturing industry, generative AI can be used in these categories of industries. So first one is music composition, film and automation, fashion, gaming and gaming. Last one is architecture. So next we'll move to excuse me. Excuse me, sorry, participants. So next we'll move to how generative AI can be implemented in the manufacturing workflow in a step-by-step process. So implementing generative AI in the current scenario is not a technological upgrade. So here we have to make a paradigm, that is, we have to make a strategic shift so that the generative AI can be incorporated in each phase of the process workflow. So we have to make a larger shift to incorporate generative AI. Since all the factories or the manufacturing sectors are moving towards automation and so smart operations, what the decision makers or the managers must think is beyond efficiency, we have to, beyond increasing the efficiency of a manufacturing system by using automation, we have to make the system intelligent driven so that it can create, learn, and adapt the ideas as set of humans. So instead of increasing the efficiency or instead of increasing the performance or an optimization, what we have to do is we have to make the system intelligence driven so that the system can make decisions like that of humans. So Gen can be implemented into the manufacturing workflow in a step-by-step process. So totally we have 7 steps. The first step is we have to identify the right use case that can be aligned with the business goals. That is the first step. Second step is we have to maintain or establish a high quality data infrastructure. Third one is we have to choose the right GenAI frameworks. Next one is we have to integrate GenAI into existing workflows. Next step is we have to deploy the pilot projects with the measurable metrics like accuracy or performance. Next step is we have to create cross-functional AI teams. Last step is we have to ensure the governance, ethic, and explainability. So these are all the 7 steps we have to follow to implement generative AI in the manufacturing workflow. Now we can look into the all the steps in detail. So first step is we have to identify the right use cases that can be aligned with the business goals. Whenever we think of generative AI in manufacturing sector, what we have to do is we have to map the AI use cases in the manufacturing industry to our particular objective to or to a particular company's objectives. Whether the particular generative AI can reduce the time or improving the yield or customization, it must produce the results in a bottom of question. In the sense, when we perform the process in reverse manner, it should be aligned with the goal and it has to produce the optimized performance. In this case, we will be using various popular applications rapid design generation for R&D teams. Next, stimulation-driven product optimization. Next one is predictive failure simulation and maintenance. Last one is defect image analysis or automated quality inspection. So this is the first step. We have to identify the right use case where generative AI can be deployed along with the performance increment, we have to produce an intelligence output. Second step in the workflow is we have to establish a high quality data infrastructure. So as we already know, AI, ML, deep learning, generative AI, everything always levies on the data that is historical data. We have to maintain a structured collection of data and also the data should be of label so that we can apply supervised learning and the data should be categorized and stored in a domain specific manner. So before implementing this generative AI, we have to check the existing missions data and the production data, and we have to create a structured database or a structured pipeline for storing the sensor data. Then that is computer aided designing files and maintenance records. And also, once we found that the data is inconsistent and there are errors or missing values in the data, what we have to do is we have to apply some pre-processing techniques and normalization techniques so that uh, the data can be useful whenever required by the GenAI models. So before storing the data into a particular repository or a collection of database, we have to make sure that the data we have to make sure that the data is without any errors or flaws. And if there are any errors, we have to apply suitable reprocessing techniques like normalization. There are multiple normalization techniques like min-max normalization, zero scale normalization. All those things we have to use it. Third step is choosing the right generative AI frameworks. So based on the company or a manufacturing sector needs, we have to choose the correct Gen AI frameworks where we can automate or we can increase the efficiency and to make the systems intelligence like human things. So there are multiple models like variational autoencoders, GAN models, transformer-based models. So we have to choose, make a choice between all those models, and we have to apply correctly to different cases in which the particular models applies. For example, we can go for using this variational autoencoder model for design optimization and anomaly detection. That is a anomaly detection. That is error detection in a particular manufacturing unit. Next, when you go for using generative adversarial networks, that is GAN, to detect the defects in the images and to synthesize the image or to synthesize the image or to generate a image data for training purposes in order to increase the efficiency or an accuracy. So we can go for using this GAN model for data accommodation purpose so that the machine data or log data, that is sensor data, can be increased. Next, we can go for using this transformer-based models for language-driven interfaces or digital twin enhancement. This is the third step, that is choosing the right GenAI frameworks. Next step is we have to integrate GenAI into the particular workflows. So what we have to do is we have to integrate the GenAI frameworks in the particular process workflows. So we have to connect the GenAI outputs to a manufacturing execution systems, and also we have to feed the results of the GenAI model to the ERP dashboards for decision making or for easy access by the manager or a customers. Next, we have to loop the generative AI recommendations into human-centric workflow also. Next, fifth step is we have to deploy the pilot projects with the measurable metrics, which is nothing but what we have to do is we have to implement the generative AI models at a smaller scale so that we can get an exact results at a less amount of time. That is, we have to make a pilot study under which generative AI can be used in various workflows of the system. We have to ensure some of the elements when we deploy the pilot projects with generative AI. That is whether we are getting a clear success KPIs, and we are getting human oversight and interpretability mechanisms, and we have to define the feedback loops to improve the models and also to rectify the errors. So we have to make clear that there should be a proper feedback loops. Next, sixth step is we have to create cross-functional AI teams. So instead of simply adopting the GenAI framework, we have to make the domain engineers or we have to make the workers at all levels, AI developers, operation leaders, IT teams, to build a collaborative GenAI models by making use of all these categories of employees. So instead of making another the employee at the top end, we have to make sure that the employees at the all the end must be aware about these generative AI models and they have no a clear idea about these models. Last step is we have to ensure the governance, ethics, and explainability. So nowadays, everyone is saying we have to create an ethical AI that is responsible AI. That is, instead of making the machines to think of like a humans, we have to make the machines to think of like a responsible humans. That is, we have to make the systems to be of responsible. That is, the system must follow the ethics to develop the models or they has to follow the ethics whenever they are making decisions or whenever they are facing a new situation they has to be ethically produce the results. For this, what we have to do is the manufacturing leaders must implement the external AI protocols, and we have to ensure the compliance with the industry regulations. And also, we have to monitor the generative AI outputs for any bias or any violation of uh, responsibility or ethics. So these are all the various steps involved in implementing the GenAI in the manufacturing workflow. So now I can give a quick recap of what are the steps. First one is we have to identify the right use case. Next one is we have to maintain a high quality data storage. Next, we have to choose the right GenAI models. Next, we have to implement or integrate the GenAI models into the existing workflows. Next step is we have to implement or integrate the GenAI models at a smaller phase by means of pilot study. Next, we have to create a cross-functional AI teams. Next, we have to ensure governance, ethics, and expensibility in uh, generating a GenAI models for a manufacturing sector. So, these ethical considerations we have to make the generative AI in producing the outputs for the machines in a bias and fairness way. Next, it has to follow copyright and intellectual property issues. That is, defining the ownership of AI creations. That is, who will be responsible for flaws or errors whenever the AI is making. All those things we have to make a sure, clear description. Next one is potential for misinformation and deepfakes. So that is compacting false information. We have to make sure that the AI is not producing any false information. Next, privacy concerns. That is protecting personal data used in training models. So that is, we have to make sure that there is a privacy for the user data used in the generation of GenAI models for a particular application. So, next one is job displacement. So, whenever we are using this GenAI models, many people will lose their jobs. So, we have to make sure that GenAI cannot be implemented in all phases of an automation. We have to make sure that when there is a need for the GenAI to be implemented in a particular phase, we can go for using that generative AI. Next one is accountability. That is determining the responsibility of who will be taking care of the generative AI models, or when they encounter errors in the model output creation, we have to make sure that who will be responsible for taking care of all these issues. So these are all the various ethical considerations we have to take care of whenever we are implementing the Gen AI models. Next, we'll move to different use cases of Gen AI in manufacturing. So first use case is design optimization. So in order to optimize the designs of for a particular machine's output, we can go for this Gen AI. Next one is predictive maintenance. Instead of workers keep on performing the maintenance task, we can implement the Gen AI models so that the predictive maintenance can be happened regularly and at a particular point of time. Next, for quality control. So in order to ensure the quality of a product designed by the Gen AI, by the manufacturer, we can go for using this Gen AI model. Next one is supply chain optimization. So in order to increase the sales and in order to predict the demand, we can go for using the Gen AI models to increase the profit for the company and also to satisfy the demand for a particular product. Next one is product defect detection. So to detect the defects in the products or to detect the issues in the products, instead of using humans for detecting the defects, we can go for using this Gen AI models. Next one to is process automation. So in order to automate the process of a particular manufacturing unit, we can go for using this Gen AI models so that it will be self-adjustable to the live demand and it can produce the products. Next one is customization, personalization. So Gen AI can be used to customize or personalize the outputs. Next one is customer acquisition and relation management. So in order to predict the customer churn or in order to reduce the churns for a particular company, we can go for using the Gen AI models. Next one is resource management. So to maintain the resources used for a particular product design or a particular product development, GenAI models can be used to analyze or to predict how much amount of resource can be used to create a particular product. Next one is real-time monitoring and analytics. So to monitor the data at real time and to make a decision, we can go for using this generative AI models. Next one is inventory management. Instead of manually maintaining the inventory data, we can go for using the generative AI and we can make decisions and we can predict the faults. Next one is workforce augmentation. So Gen AI can be used to assist the humans in augmenting the real-time data and to make the decisions. Next one is enhanced decision making. So in order to make the decision making correct and stable, we can go for using the Gen AI models. Next one is energy management. So to predict the how much amount of energy is required for the particular product design, we can go for this Gen AI models. So next one is future trends in generative AI. First the trend is multimodal AI. So we can go for using different types of data, text, images, audio, and video to be used for generating a model. That is the first trend. Next one is the improved control and fine-tuning capabilities for more precise outputs. To generate an exact outputs, we can make capabilities of a Gen AI to be increased. Next, we can incorporate Gen AI with the robotics for automating the task of a particular person. So instead of running the light by a human, we can go for using a model to a model or a chatbot to switch on the lights. Next one is enhanced explainability and transparency in AI decision making process. Next one is quantum computing integration for complex generative models. So nowadays quantum computing is getting a trend. So we can go for incorporating quantum computing with generative AI so to make a decisions. Next one is federated learning for privacy preserving and model training. Next one is emotional and contextual understanding in generating the content. So instead of generating the content simply, we can make the model to generate the content by understanding the needs in detail and produce an exact output. Next, we'll move to challenges and opportunities in generative AI. So we have to make a balancing creativity with accuracy and reliability. That is the first challenge. Next one is we have to create a robust evaluation matrix for the content that has been generated by the Gen AI models. Next, we have to explore new business models and job roles in the AI era. Next, we have to address the social impacts and developing regulatory frameworks. That is, what are the impacts we face whenever we incorporate generative AI in automation, and we have to create a regulations, and we have to enhance energy efficiency, reducing impact of AI training. That is, whenever we keep on using machines, there will be a loss of energy or there will be a pollution. So we have to keep track on it. Next one is we have to democratize access to generative AI technologies. That is, we have to make an awareness of Gen AI technologies to all the people. Last one is fostering human AI collaboration rather than replacement. So instead of replacing the human workforce in the industry by automating the process workflow, we has to make an AI collaborate with the humans to produce an output that is of optimized rather than replacing the humans. So with this, I complete the today's sessions. So we have seen what is generative AI and various use cases and various steps involved in implementing the generative AI in manufacturing sector. Next, we have seen the future trends in generative AI. At last, we have seen the challenges on opportunities in implementing the generative AI. So thank you. Participants, if you have any queries, you can post.
Participants, please, if you have any queries, you can post.
Good afternoon, sir. This is Srinivas. Sir, what kind of infrastructure and data readiness is needed to deploy generative AI in industry, sir? Sir, good afternoon, sir. What kind of infrastructure and data readiness is needed to deploy generative AI in industry, sir? Hello? Hello? Sir?
Sir, sir, are you
Sir,
there?
I think sir is not there.
Okay, on behalf of
Hello.
all the participants, I
Hello.
would like, hello,
Sir, sir.
Ma'am, sorry, there was a network connection. I could not hear. Sorry.
Okay, sir. Sir, once again.
Srinivas sir, you can again ask the question. Sir is
Okay, ma'am.
available.
Okay, ma'am. Thank you. What kind of infrastructure and data readiness is needed to deploy generative AI in industry, sir? What
So
kind of?
yeah, we must have a historical data about all the process workflows, and the data
Okay,
should be
sir.
of easily used by the models. It should be without any errors or flaws. That is enough. But full historical data we require from top to bottom.
Okay, sir. Okay. Thank you, sir. Thank you for your explanation. Thank you, sir.
Thank
On
you.
behalf of all the participants, I would like to extend our heartfelt gratitude for your insightful and engaging session, sir. We truly appreciate the time, effort, and
Thank you, ma'am.
expertise you
Thank you.
invested in preparing and delivering such a meaningful session. Thank you once again for contributing to the success of our FDP and for motivating us, sir. Thank you, sir.
Thank you, ma'am. Thank you, ma'am. Thank you.
Okay,
Thank you,
okay.
participants. Thank
Okay,
you.
sir. Thank you, sir. It's my privilege to invite and introduce our eminent speaker of the second session of today's FDP program, Dr. K. Narasimhalu, professor in the Department of Biotechnology at the prestigious NIT Warangal, as the speaker of this second session. Dr. K. Narasimhalu has over 25 years of teaching and research experience in biotechnology and allied domains. He earned his PhD in biotechnology from NIT Warangal, MTech in biotechnology from JNU Hyderabad, and BTech in chemical engineering from NIT Warangal. His areas of expertise include bioprocess engineering, biofuels, environmental biotechnology, and the application of AI and machine learning in bioprocess engineering, where tradition meets tomorrow. Dr. Narsimalu has guided four PhD scholars and supervised numerous UC and PG research projects. He has successfully completed six sponsored research projects funded by SIR, DST, and MHRD. He has authored over 40 research papers in reputed high impact international journals and has delivered expert lectures while organizing FDP's workshops and conferences at national and international levels. He has also served as a visiting researcher at Rice University, USA. His accolades include the DVT International Travel Award, Young Faculty Award, and Young Scientist Award from the Venus International Foundation. He is an active member of several national and international scientific societies. I extend a warm and heartfelt welcome to Sir. Let us join in warmly welcoming Dr. K. Narsimlu. Sir, please continue.
Yeah. Thank you, madam. Am I audible?
Yes, sir.
Is my screen visible, ma'am?
Yes, sir.
Sir, you will continue.
Sir, screen is visible, sir.
Okay. Good afternoon, everyone. Today's my topic is interdisciplinary applications of large language models across engineering, healthcare, and management. So large language models are artificial intelligence based computational models. Actually, they have been designed to understand and generate human-like text. Here, with billions of training parameters, LLMs excel in identifying intricate language patterns, enabling remarkable performance across a variety of natural language processing tasks. These are driving significant interdisciplinary and transformative changes across engineering, healthcare, and management, primarily by automating unstructured data processing, enhancing decision making, and augmenting human expertise. So they leverage transformer architectures and even large scale domain specific training to bridge gaps between complex, unstructured information and actionable insights. These LLMs are sophisticated systems. They are built using deep learning techniques, primarily leveraging the transformer architecture, so to process sequential data efficiently. So these models undergo large-scale pre-training using vast data sets to capture semantic and syntactic patterns. So the concept of scaling laws is very crucial to their performance, as it highlights how increasing both model size and data can lead to significant gains in understanding and generating human-like language. That is more important nowadays. So the capabilities of these LLMs are fundamentally rooted in three key elements. One, advanced language modeling to predict and generate meaningful text sequences. So the transformer architecture for managing long-range dependencies in text. And third one, extensive pre-training, which equips the models with broad conceptual knowledge applicable across domains. Here, you see the different types of models are available. So here, if you see the traditional NLP models, if you look at them, so they're actually usually they require less data and computational power. So these traditional NLP models can be trained on smaller domain-specific data sets, making them more accessible for specialized applications. We can use them wherever we require to use specifically. But here, their performance may be limited when dealing with very complex language tasks that require broader conceptual understanding. So generally, they are rule-based and systems and statistical models. So here, the main thing is that they're limited. They have limited ability to understand long text context. So they heavy dependence on handcrafted features and poor generalization to new or unseen data. Only known data can be processed here very easily. Otherwise, they face the problem here. The best examples for traditional NLP models are like keyword matching, bag of words, n-gram models like that. The main limitation of traditional NLP models main is they could not capture meaning, semantics, or even complex language patterns effectively. But for small words, they can easily catch up. So if you look at the second thing, neural networks in natural language processing, you see. So here the machine learning models are used as a neural network models. And mainly, the neural networks are machine learning models that mimic the complex functions of the human brain. These models consist of interconnected nodes or neurons that process the data, learn patterns, and enables tasks like pattern recognition and decision making, mainly unsupervised learning. They don't have any labels for that, but still they can learn the data by using patterns. So here the text converted into numerical form using the word embeddings like word to wake, gloway. These are the examples. Neural networks have been like NLP models, a huge capacity for understanding and simulating a human language. They are very much helpful here. So they have allowed missions to predict words and address the topics that were not part of the learning process. So to achieve this performance in NLP processes, the neural networks must be trained with large amounts of documents according to the type of text or language to be processed so that they can work better. So in NLP language models, neural networks act in the early stages, transforming vocabulary words into vectors. This is the main application of neural networks in NLP. Okay, so they act based on the principle that in a text, the meaning of a certain word is associated with the words found around it, so that they can easily capture that one. So these vectors are used in simple operations to provide reasonable results in the semantic level. So like that, neural networks will be helpful. So they have the better sequence. So the main advantages are the key models here in neural networks, like recurrent neural networks are generally used, and another type, long short-term memory networks, LSTMs, they are also used here. These are the models mainly used. The main advantages of neural networks in NLP, if you see, they handle better of sequential data, like sentences, paragraphs can be handled very easily. So learned representations, they automatically. So they will learn representations automatically. They improve the context awareness compared to traditional methods. When you compare with the traditional methods, these are better. But we have limitation also here. It is difficult in remembering very long sequences by neural networks. Uh, they are slow in training due to sequential processing because they go in a sequence, like in form of neurons nodes. They go, so the process is slow somewhat when you compare with traditional ones. So they face the gradient, exploding gradient problems here. Next, if you see the transformer architecture, so here the transformer architecture is like, attention is all you need, like that. So it allows the model to focus on relevant words regardless of their position in the sentence. Only it will capture the relevant words, whether they are present in sequence or not, it doesn't matter, but it will take directly. And the main advantage of transformer architecture here is that the parallel training is possible. Like this one is faster than RNNs and LSTMs, and they have better long range context understanding. So large sentences can also be understood by transformer architecture, and it will scale efficiently with the data, and it will compute very easily. So we can overcome memory and speed limitations of RNNs and LSTMs with transformer architectures. So that's why transformer architecture became the foundation for modern natural language processing systems. So now if you see the contemporary large language models here, so these are the very large transformer based models like GPT-4, LLMA. So the main features of this, like they can handle hundreds of millions to like billions of parameters. Yeah, they are trained on large text words. Okay, they are capable of like a complex reasoning and contextual understanding, multitask learning. So the main capabilities, they can generate the text very easily. Even a large text can also be generated by using that, and they can answer the questions. They can summarize the matter. The code will be generated based on the requirement, and conventional AI is used here. So when it comes to the applications in healthcare and other domains of LLM, yes, so mainly they are used in clinical decision support, medical report summarization, drug discovery, and biomedical literature miming. So patient interaction, chat words like that. So apart from that, there are many domains available. So like that, LLMs are used in various fields. Now, if you see the picture here, how these LLMs are used. So the unstructured data, if we have here, unstructured data may be available in form of PDF, that may be like in form of Word files, text files, okay, Excel sheets may be available, emails, social media, websites, videos, messages, all these are unstructured raw data. This data has no fixed scheme and cannot be directly queried or analyzed by traditional databases. They cannot be handled. So here if you see the content is also unstructured. The word cloud highlights which exists inside this raw data. Okay, all these entities, names, places, date, language, all are different. So at this stage, data is human readable, but mission unfriendly. We can read the data, but machine cannot understand directly. So what we have to do here, this thing must be processed. Okay, we can process this data by using a private large language model, LLM again here, so that it will process the unstructured data. What it will do here, it will extract the text from these, like from PDFs and from docs. So it will extract the data, and it will understand the language and context which is available in form of all these. Okay, so it will recognize the entity maybe with names, values, events. It will segregate. This LLM will segregate after taking from this. So it will separate and it will classify and it will tag also. Once the values and names, they're classified or segregated, and they will be labeled, so that it will indicate the data security and confidentiality, so that within the particular organization, and it will be available for further process. So then what will happen here, the LLM will convert the raw content into meaningful knowledge, so that it will summarize and the relationships between the concepts available, schematic understanding, like that. Data will be transformed into the knowledge. Okay, data will be transformed into the knowledge. Whatever it is segregated here, it will be transferred into the knowledge. Then from here also, the structured data available here, which is already segregated, which is already labeled, will be extracted as a structure, because it may be in form of tables. Okay, we can do that. We will use rows, columns, like that. We can make the table particularly based on they are very specific, the values, names, like that. So this steps makes like we can easily search where it is available, what type of values are there, like that, and they are also audible, like that. And metadata can also be taken here. Maybe so what is the source from where this data we got, okay, and what is the document ID, like various sources we have used here and they are processed here, and we will finally segregate. So document IDs are also identified. Like that, this structured data feeds into the reporting and dashboards finally. So after this, like we can use the dashboards and analytical systems. We can easily identify what are the data points available here. So here, if we look at the chatbot, it will do the same knowledge base powers a chatbot using this knowledge unstructured data. The same knowledge base it powers. So humans can ask natural language questions now because it is already information is segregated. Knowledge is unstructured data is available in form of knowledge. So now we can ask, tell me about the documents like that. If you ask this, then even what is the latest update like that we can ask. So the chatbots retrieves the answers grounded like in structured data, okay, here, and extracted knowledge. Structured data which is available here and extracted knowledge. Both will be utilized by the chatbots so that the same information will be stored securely and we can access whenever it is possible. And of course, we can also control that one. And almost same here also, unlabeled data will be collected maybe from Wikipedia, okay, and the process it begins with large amounts of unlabeled data we can get here, okay, maybe Wikipedia articles, books, web pages, documents like that. So unlabeled data will be available, so we can take it. The model here, the actual model, it learns the general language patterns, maybe grammar of that, what are the facts available here, or what are the relationships available directly from raw text, this model will understand. So here the main key idea is to get the large amount of data which is available in a particular source. So diversified data will be taken here. Okay, that will be pre-trained here actually. So before the model takes this data, the data will be pre-trained. So this during this pre-training, what will happen? The model predicts massive words or next words in sentences like that. The matching words will be identified very easily. Okay, it learns syntax, semantics, reasoning patterns, and world knowledge which is available. Okay, in form of articles, books like that. So this is the task agnostic, not focused on any single application, but in general, it will get the information. So finally, it will learn how language works than a specific task. So it is mainly based on the type of language. And then foundation model will come after pre-training. So after pre-training, the result of pre-training is the foundation model after pre-training. So then the main characteristics of this foundation model are like a large neural network is utilized here. General purpose intelligence is also utilized, and it can understand and generate language across many domains. Okay, and at this stage it is powerful but generic, not very specific to a particular task. It can be utilized for generic purposes. So one model that can support many downstream tasks, this is the model we have, then it can be adopted to a specific domain. Okay, it can be used and to summarize the to summarize the information, fine tuning on domain specific data, maybe related to medical, legal, or scientific data. Okay, and reinforcement learning from human feedback. So all these can be used. Mainly, it is used to adapt the general intelligence to specific needs. That is the main purpose. So that finally, it condensing the long documents after summarizing, so answering the questions accurately, and conversational assistants will be utilized in form of course, chatbots. And one foundation model can cover multiple applications here. So these are the applications which are utilized. So finally, here unlabeled data is pre-trained, so that foundation model is developed using an even neural network, and also so that that will be domain adaptation will be done, and finally applied to specific application we can use specifically wherever it is required. So this type of architecture is also very important. It reduces the need to train separate models from scratch. It's not required, because from the source data, a model can easily be built. It enables the scalability across the domains, many domains available. So it forms the backbone of modern AI systems like large language models. Now, come to the applications as per our title. So it is large language models are used in engineering domain, mainly design and product development. Engineers use large language models to generate, simulate, and optimize designs for components. Example, like in automotive design. So Toyota Research Institute unveiled a generative artificial intelligence technique to amplify vehicle designers. So here, currently designers can leverage publicly available text-to-image generative AI tools as an early step in their creative process. So with TRI's new technique, designers can add trial design sketches and engineering constraint maybe like a drag, which will be affecting the fuel efficiency into this process, so cutting down the iterations needed to reconcile design and engineering considerations. So here vehicle design sketch incorporating the results of TRI's new generative AI plus optimization technique, both are combined together so that the design can always be modified based on the requirement. Here, if you see, a designer can request a text prompt, a suite of designs based on an initial prototype sketch with specific stylistic properties like sleek, SUV-like, and modern. Based on our requirement, we can always give the requirement. So here, constraints like drag. Okay, so if you see how many iterations are required to have the required design, so the drag which affects fuel efficiency and chassis dimensions like ride height, cabin dimensions which affect handling and even safety also. So it can easily be incorporated into the generative AI process. Okay, so the team tried principles from optimization theory used extensively for computer-aided engineering to text-to-text based generative AI. So the resulting algorithm allowed the designer to optimize the engineering constraints while maintaining their text-based stylistic prompts to the generative AI process. Yeah. So the main components required here are like functional requirements, what are requirements, constraints, maybe cost, weight, safety, like that, and material properties. Okay. And if you see here, optimized geometry will get finally reduced weight and cost, improved performance. So these are the main applications of that. So the new generative AI technique optimizes aerodynamic drag in successive iterations based on parameter inputs from the designer. But iterations manually, if you do, so it will take long time. So if we use that generative AI technique, it will optimize the conditions and number of iterations will be less. And it is all based on the design, what type of design we require. So But finally, the time consumption will be very less here. So we can reduce the time requirement so that the rate of whole process can be increased here. Now, another application area, that is software engineering and code generation. All of you know that our large language models are extensively used in software engineering and code generation. So mainly these are used to debug and translate the code across multiple programming languages, speeding up development lifestyles. So generally here we can see the code generation. Suppose here a, AI or robot working on a laptop, and it will write the code from natural language prompts. Okay, so like generating functions and even codes will be generated, entire models will be developed here. Then it will be debugged. So here, how it will show how LLMs identify the errors, okay, and explain the bugs, and it will suggest the fixes also, how the errors can be fixed. It will be done here in debugging. So here, finally, it will be useful for syntax errors, logic bugs, and finally, hints will be optimized. So it will be transformed into the code. Code will be transformed. So here, if you see the Python to like JavaScript, from one language to another language, it will be done here. Okay, so LLMs will also be helpful to translate the code between the programming languages, because sometimes our code will be available in one language, and we may have to convert them into other language. It will be done here also using LLMs. So here, finally, we can develop the human AI collaboration. Okay, but it is not the replacement, but still both must work together. So developers guide the process, whole process, while LLMs accelerate the tasks here. So we can reduce the time, and we can move the actions at a faster rate. So like here, Python, JavaScript, and C appear. They are the developers mainly used here. So they support LLMs. Finally, support multiple programming ecosystems, so making them versatile tools. They can be used specifically wherever they are required. So, and the mainly, if you see, the machine intelligence will be utilized here, learning from large code bases, text aware reasoning in software engineering tasks, everywhere they are used. So in the whole domain, LLMs accelerate the software development. They assist in coding, debugging, and language translation. And they also enable faster, more efficient, and collaborative software engineering workflows. Like that, LLMs will be helpful. Now, there is another domain like predictive maintenance and supply chain. So here LLMs analyze sensor data and maintenance logs to predict machinery failures, like mainly in automotive industry, and manage supply chain disruptions. So here, if you see the predictive maintenance, here LLMs analyze sensor data maintenance logs to predict. Okay, so if you look at the car on an automated service platform, and it represents industrial or automatic equipment. Okay, so here if we look at our robotic arms and sensors, they indicate the continuous data collection like temperature, vibration, pressure, like that. And here the warning icon will will give the detection of anomalies which are available. And if you see this chart, okay, what is the performance of this car will be recorded here. Okay, if there are any faults, that will be detected here and will be shown. And the AI system mainly predicts potential failures before breakdowns occur. So like that, predictive maintenance will be helpful. And of course, here also LLMs are used. So LLMs combine real-time sensor data with historical maintenance logs. So that what will happen, we can predict the component failures. We can schedule maintenance in advance before before damage happens. And it will also reduce the downtime and repair costs. Like that, in predictive maintenance, LLMs are utilized. And here the AI will be utilized after predictive maintenance. So it will act like intelligence hub. Okay, so it integrates the data from missions, whatever we have taken the data from the missions, warehouses, or transport and logs, and it will generate actionable predictions and alerts. Like that, it will be helpful. Okay, so the LLM connects maintenance insights with supply chain decisions, even in optimization. So here we have the trucks, warehouses, and delivery routes all are indicated. Uh, this is nothing but the product movement. So data flows and the network lines, they represent real-time tracking. Real-time tracking. So delay alert, warning indicates disruption detection. So the mainly LLMs analyze the delivery schedules here, inventory levels, transport delays, supplier disruptions, like that. So in the center, AI will take care about the predictive maintenance and the supply chain optimization both. Finally, all this will be maintained again by human and AI collaboration. So human operators monitoring AI insights here, and decision making will be taken by AI. Okay, so overall, if we see what is there here, LLMs transform maintenance and supply chains from reactive systems into predictive, resilient, and intelligent operations. So next, technical documentation and knowledge management in engineering. In this domain also, LLMs are useful. So LLMs automatically summarize, organize, and retrieve information from vast repositories of technical documents and reports, whatever it is available. So it can easily be restored here. So here automatically they summarize, organize, and retrieve information. Okay, and mainly they represent like engineers will work here, researchers will work, analysts will work. So the structured summaries are available, highlights, extracted insights, all are available. So from this, what we can come to know, LLMs transform unstructured documents into usable knowledge. That's what we have already seen that. Okay, so here also, if you see in form of many documents, like stacks of papers, files, reports, okay, like that. So information overload without AI support, lot of information is available. So we can see we can search and retrieve the information here. We can verify, okay, and we can extract the knowledge from the information available in any form. Okay, we can access the control and secure the information using large scale models. So finally, of course, again, human and AI collaboration must be used. So in this, LLMs will be utilized to reduce the time spent searching through documents, okay, improve knowledge reuse and organizational memory, enable faster decision making and onboarding. Like that, LLMs will be utilized here. So they finally ensure consistent, up-to-date technical documentation. So LLMs convert massive technical document repositories into searchable, intelligent knowledge systems. That is possible. This is like how LLMs are used in engineering. Now, if I see the other domain, healthcare and medicine. So LLMs are transforming healthcare by improving clinical workflows, diagnostic diagnostic accuracy, and patient engagement. These are capable of transforming healthcare by demonstrating remarkable capabilities in language understanding and generation. So this can enhance patient education by providing accurate, readable, and empathetic responses, and they can streamline clinical workflows through efficient information extraction from unstructured data like clinical notes. So integrating LLM into clinical practice, it involves user interface design, clinician training, and effective collaboration between artificial intelligence systems and healthcare professionals. So users must possess a solid understanding of generative AI and domain knowledge to access the generated content critically. So here if you see the clinical decision support and decisions. So here we mainly see here doctor and the nurse, they are talking to each other on a laptop. They are searching clinical, their expertise, okay, and they have to take some decision based on the patient's disease. Okay, so a friendly a robo stands beside them, and it will represent LLM based systems that support healthcare professionals. How LLMs support healthcare professionals, we can understand from this. So medical, here if we say the X-ray, heart rate, okay, like that in the background, they indicate the clinical data integration. Finally, from this figure, what we can understand, AI works alongside clinicians, okay, augmenting, not subtracting, but medical judgment can be done here. So now here, if you see the dermatological diagnosis, tools like Skin GPT-4 assist in analyzing the skin conditions. Okay, this is available, and it will be used to analyze the images of skin lesions, rashes, or pigmentation patterns like that. Okay, so early screening of dermatological conditions can be done here. So decision support for dermatologists will be given. Okay. Improved access to tele-dermatology, and it is possible here. Okay, so the ambulance and here, if you see next emergency department tries, LLMs aid in assisting and prioritizing emergency cases here. Okay, they use GPT-4 and Medpal to help assess symptoms, history, and important aspects to prioritize urgent cases. Okay, so they will increase the triage decisions. Okay, reduce the emergency department overload, support during a peak patient influx. Next, if you see the drug interaction and identification, detecting harmful drug interactions and contradictions can be done here, so that pill bottles and pump, they are used here. Medication safety, we can understand from that. Drug to drug interactions and contradictions can be identified here. Finally, here the AI models utilize GPT-4 by OpenAI Okay, it is used for clinical reasoning, for summarization and decision support. And MedPal M2, okay, this is by Google. This is also available, and a medically fine-tuned large language model, MedPal M2. So it is designed for healthcare question and answers and clinical understanding. Okay, this Skin GPT-4, it is a specialized dermatology-focused AI tool for only skin image interpretation. Like this, AI tools are utilized in clinical decision support and diagnosis. And medical documentation and administrative efficiency, here also AI tools are utilized and LLMs will be utilized here. Okay, so we can review the records, okay, and real world clinical practices what are available like that. And again here also a supportive a assistant like robo symbol, okay, it is LLM working alongside healthcare professionals always. Okay, so here they indicate voice to text transcription can be done here, and structured documentation will be utilized here. So finally here, AI assists clinicians by handling repetitive documentation tasks while clinicians focus on patient care. Okay, so the documentation segregating and everything will be taken care by the LLMs, so that doctor can focus mainly on patient care. Otherwise, he will have more work on documentation. That part will be taken care by LLMs. So here, doctor-patient conversations will be utilized. Lab and image summarizes will be utilized here. So automated clinical notes will be generated. LLMs automatically generate accurate clinical notes from patient encounters in real time. Okay, so here the SOAP notes and discharge summaries will be used here, and we can create the structured SOAP notes and detailed discharge summaries with relevant information. SOAP means like subjective, O is objective, A is assessment, and P is plan. So with respect to all these notes are like prepared. SOAP notes, discharge summaries and referral letters will be prepared by default automatically. Okay, so that we can standardize the documentation using our LLMs, so that our doctors will get free time. Okay, better continuity of care can be done, it can be possible. So clear communication across departments will be possible, so that we can doctors can spend more time with patients. In that, LLMs will be useful. Okay? LLMs will here allow the clinicians to spend more time with the patients, improve work-life balance, reduce documentation work mainly. Okay, the administrative burden is one of the leading causes of burnout. In that, LLMs will directly target this issue and solve the issue. So the main models utilized here also same GPT-4. This is advanced language understanding and summarizing. So MedPal into medical domain optimized reasoning for clinicians, LLMs, hospital, okay, like that. All these are utilized in the medical documentation and administrative efficiency domain. And even here in radiology and pathology, of course, all these fall under the healthcare and medicine category. So here MRI scan, CC and the CT scan here, they represent different imaging modalities used in clinical practice. So MRI provides a high soft tissue contrast like brain tumors, but CT offers fast, detailed cross-sectional views like lungs, bones, like that. So here the multimodal LLM, multimodal LLM will be used here. So it will process the visual data. Visual data means MRI, CT images, okay, and textual data like clinical notes, peer reports, patient history, all will be utilized. Both will be processed here. So once they are processed, then it will be converted into the automated diagnosis. Generated report will be done. So here if you see the main findings, large mass in the left lung with medically, okay. In that it is available information suggestive of primary lung cancer, further oncological evaluation recommended, like that suggestion will be given based on analysis done here. So report will be generated, primary lung cancer, like that. Okay, recommendation will be referred to oncology for biopsy and staging. Okay, follow up PET scan advised, like that. So here the decision can easily be taken based on the analysis done by our multimodal LLMs. Okay, accurate assessments can be done so that we can see the improved detection and interpretation, and integrated analysis like images and text analyzed together, so that we can use this integrated analysis, and high quality reports will be generated. They are very clear, standardized and actionable outputs. So here multimodal multimodal LLMs transform radiology and pathology workflows by integrating multimodal data to deliver faster, more consistent, and clinically meaningful diagnosis reports, so that we can enhance so the whole process very easily. Next, if you see the drug discovery and genomics, LLMs predict molecular properties, identify novel compounds, and analyze DNA sequences to predict variant effects here. So, if you see stages in drug development, to develop a particular drug, a lot of stages are involved here. Initially, we have many compounds. So we have to take care about all compounds. They'll be screened in the first level where the basic research is involved. We identify and design many hit compounds. Okay, maybe like 5,000 to 10,000 compounds. So here, the synthesis and optimization of lead compounds will be done. In vivo models are utilized here in the first stage because basic research is involved. So in that, AI is utilized to identify the new targets, to predict the target's role in the disease, a particular disease, and it will also predict the signaling system. Okay, and it will predict the new compounds. Synthetic roads will also be designed here in the first stage. In the second stage, like a preclinical phase, most of them are screened. Finally, 5 compounds, prediction like toxicity. What is the toxicity which will be utilized? But it takes a lot of time, like 6 to 8 years. Okay, finally, 5 compounds, 6 to 8 years. Extensive safety and toxicity testing will be done before human trials. Toxicity will be predicted here, and potential side effects will be identified. So in the stage 3, this is the clinical phase. So in this clinical phase, again there are 3 phases: phase 1, phase 2, phase 3. And in phase 1, like a small group of healthy volunteers are invited. They'll be taken into the research. Okay, and safety and dosage will be considered here. And in the phase 2, patients with the disease will be considered. Once the clinical trials will be done on volunteers, then in the phase 2, it will be done on actual patients with the disease, a particular disease, so that efficacy and the side effects will be known here, mainly. In the first phase, only whether our drug is safe or not, it will be tested, and how much dose we can use. Okay, we will come to know. Once we know that, yes, the drug is safe and this much dose can be utilized for that, then actual patients with the specific disease will be used here. From this, what we will come to know, whether drug is efficient or not, whether there are any side effects are there or not, we will come to know. Next, we will go for phase 3. This is also like 8.5 years, and next phase 3, lot of years, like 10.5 years. Large patient population will be considered here. So mainly to confirm the effectiveness of the drug, finally. Okay. So once it is, but here, what is the AI role? In this, a lot of time is utilized manually in the drug development. But what AI will do, this AI will do the drug repurposing, like, finding new users for existing drugs. Okay, patient population selection, adherence monitoring, trial optimization, like that, so that the whole time can drastically be reduced by using AI. Okay, this is the general procedure, and AI will reduce the whole time process, so it can be done in days also. Okay, not in many years. So finally, what happens in the regulatory phase? They will review the clinical data, and decision will be taken whether it should be approved or not, like that. And finally, one drug will be approved. Okay, one drug will be approved like this here. So the 10,255, finally, one drug will be approved, and this drug is monitored after market release. Okay, and modeling signal pathways will be tested here. So large libraries of molecules are screened to find hits. So everything will be done here. Once that phase is over, we can go for pharmacovigilance. Pharmacovigilance. That in that, even AI will be utilized, detecting rare or long-term adverse effects using real-world data. So because data can be collected, that can, here how AI will be utilized here in this stage also, the data can be collected and it will be segregated, it will be labeled. Okay, patterns will be decided by using even supervised learning, unsupervised learning, reinforcement, that will be optimized. Finally, real world data will be utilized finally to finalize the long-term adverse effects of the drug approval, so that it will be in a continuous use. Okay, so finally, in the whole process, AI will improve the speed and it will improve the accuracy, and it is like cost effective, and success rates will also be more in this, because with accuracy will be more, huge amount of data will be dealt with AI. That is the main reason. Otherwise, physically it is not possible. So AI helps convert thousands of molecules into one safe, effective medicine here. So like that, the AI will be utilized. And here also, we can see the user, maybe a patient, health information will be gathered, pre-procedure guidance, medication clarification, appointment or building if. So suppose if you give some voice, so it will be converted into the text. Okay, that text voice conversion will be done by AI, and this makes the system accessible, especially for elderly or low literacy users. Okay, so then it will convert voice into text, identifies the keywords, intent and context, and this step ensures the query the structured and mission readable. Okay, so finally it will be scaled. So real-time updates will be utilized, and natural language processing systems will simplify the medical jargon, maintain the empathetic tone. It will translate into the regional languages. Finally, information will be available. Like that, large language models will be utilized in this healthcare sector. Now, management and business operations. Here, large language models are transforming management by shifting from simple chatbots to autonomous agents that automate complex workflows, analyze vast amounts of unstructured data, and enhance decision making across various business functions. Their interdisciplinary nature allows them to bridge gaps between technical systems and strategic business goals. So here, if you see the customer support and sentiment analysis, advanced chatbots provide 24/7 personalized support here. So while analyzing customer sentiment from social media and support tickets to improve the products. So what are the tweets available every month? Tweets by hour, okay, based on months, and who are the users, how many tweets they made, what is the percentage, like that. In form of charts, we can segregate tweets frequency by month and by which sources. Okay, finally, sentiment distribution can be done. Finally, so we can see exactly how sentiment is distributed. We can do analysis part. Customer support can be very easy once we do the sentiment analysis. So here next, the process of fraud detection system in management, it is very, very important. So here what happens, so the records and information of the users, the process here, it starts with collecting the user details, okay, like identity, data, account history, device information, location, past transaction behavior, like that. So this data forms a baseline profile of any user behavior. Okay, this is the first step. Yeah. So then all user records and transaction data are aggregated, cleared, and structured. Okay. So here. So what A and ML will do here, these A and ML techniques pre-process the data by removing noise and duplicates, and normalizing the values, extracting the relevant features like amount, frequency, location, timing, device, etc. So here, once it is done, machine learning models will analyze the transactions in real time or batch mode. Next here, okay. Once it is done, after aggregation, clearing, and structured, so then analysis will be done here. Okay. So here the system compares each transaction against learned normal behavior patterns, non-fraud patterns, okay, and suspicious or anomalous transactions are they're flagged here. Okay, so then based on the risk score here, then we can see if the risk is low, transaction will be approved. If risk is very high, then transaction is blocked. Okay, and if medium risk is there, then additional authentication will be asked. Like, we can request for OTP, they'll request for OTP, biometrics, like that. So there is a feedback loop from this step back to the detection model to improve the decisions. Feedback loop. Okay. So this will confirm the fraudulent transactions which are stored. Their characteristics become new training data. okay, helping the system recognize the similar fraud attempts in the future. So abnormal financial transaction information is also available here. Detailed records of abnormal or fraudulent transactions are maintained. So this data feeds back into the AI training pipeline here. Okay, this will take the actual user data, okay, and also fraudulent data also, strengthening detection accuracy. It is useful here. So the entire system is continuously monitored and audited. So like that, we can detect the fraud which happens in any, maybe mainly in credit card system, bank system, finance, like that. Models are retrained to adopt to new fraud techniques and evolving user behavior. It will become very easy. So here also AI and ML techniques are utilized in management especially. So mainly a closed loop self-learning fraud detection system will be utilized. So finally, AI and ML continuously learn from the past fraud. They improve the detection and reduce future risks while ensuring secure and smooth user transactions. Like that, large language models are utilized in engineering, healthcare, and business management, the business operations. Okay. Thank you. Any doubts, so please ask. So this is about my presentation. Talk.
Sir, good afternoon.
Good afternoon.
Yeah, you have covered many aspects. So, healthcare applications with LLM and all. So, it's a great session. But one thing, like how this big data is being handled in real time,
Madam?
how this much of LLM it is just producing lots of volumes of data. So, then how in real time systems like thermodynamics and healthcare systems, how this data is being controlled, and how exactly secure, if at all any errors are like
Yes,
errors, how they are.
errors will be identified, and larger. That's what, madam. Because we produce a large amount of data, that
Yes.
data will be segregated actually based on the type. That may be in terms of value, in terms of name. So all will be segregated, and they will be stored in form of a table like that, so that it will
Okay.
be easy to identify next time. And
Okay.
the model will be trained with the input data what we give. So next time it will easily identify and it will save the time.
Is it like through feedback loop?
Yeah, obviously, feedback loop is always helpful at every stage.
Okay. What if at all any data is lost in real time?
That can be rectified.
Okay.
That can be like retrieved. Data
Retrieved.
can be
Okay.
retrieved always.
Okay, sir. And in aerodynamics also, can I see that aerodynamics slide, please? Yeah,
Is it
sir.
visible, madam?
Yes, yes.
Oh.
Sir, is it like the designing aspects, uh, text to, the conversion is from text to something you said, no? That I couldn't get it. Because in real time, when the optimization,
No. Actually, here, like customers will give their preferences. Like a text prompt means we will tell.
okay,
Like
this is just like,
maybe we will write what exactly we need. Like we need a sleek design. We need SUV like modern, like that. Okay,
okay,
based on the text available from the customers. Okay, so because every time customers cannot go directly to the manufacturer and tell what exactly they require. Okay.
yeah, because in DRDO, they are very much particular about this noise erosion and all.
Yeah.
So then they are also asking us to just frame it like for the projects. So for that purpose, I asked this question. Anyways, sir, like a very good presentation. Thank you so much.
Thank you.
Sir, good afternoon, sir.
Good afternoon.
This is Srinivas.
Sir.
Sir, how can LLMs can be used in critical decision support systems without violating safety norms, sir? LLMs used in critical decision support systems, sir, without violating safety norms, sir.
Without violating safety norms,
Yes,
in the
sir.
sense
Safety norms,
accuracy is more here. So they will not violate any security.
Yes,
Because
yes.
the data is stored, lot of data is stored in a particular system, so that
Yes, sir.
there is no problem with the security. They will not violate.
Yes, yes. Sir, what is the scope of LLMs in research work, sir?
Obviously, whatever we have considered so far, maybe in designing a particular car, okay, it is used, and in healthcare also it is used, and in management of in identifying the defaults, okay, we have used it, okay.
Yes, yes.
Everywhere LLMs are utilized, but in which form, what is the model we use, based on the requirement, we can select a particular model.
Yes, sir. Yes. Thank you,
Because
sir. Thank you.
sometimes neural networks will be utilized, sometimes reinforcement learning technique will be utilized, okay, like that.
Thank you, sir. Thank you, sir.
Okay.
Good afternoon, sir.
Yeah, good afternoon.
Sir, like in multimodal image diagnosis, so in biomedical applications, sir, can the feature extraction or feature selection will be done by this LLM model, or just for just a generalized report it will be generated, sir?
No, this is also LLM model, but only thing is that with large data available, so it can be data can be extracted very easily. But only one model is not utilized here. Combination of different models we will use there.
Okay, sir. Then can it replace then the other learning models, or simply we can extract?
We can combine two LLMs,
Okay.
and so that large amount of data can easily be extracted. That is the main purpose.
Oh, okay, okay. So we can create a hybridized model where we
Yeah,
can both
hybrid
those.
model.
Yeah,
Yes.
yeah. Okay. Thank you very much, sir.
Thank you.
On behalf of all the participants, I would like to extend our heartfelt gratitude for your insightful and engaging session today, sir. We truly appreciate the time, effort, and expertise you invested in delivering such a meaningful session. Really, sir, it's very helpful and very informative session. Thank you, sir. And in future also, we would like to collaborate with you, sir. Thank you, sir.
Thank you, madam.
As
Can I
we,
leave, madam?
yeah, yes, sir. Thank
Okay.
you, sir.
Thank you.
As we come to the end of this session, I would like to express our sincere gratitude to our distinguished speakers for generously sharing their knowledge, experience, and valuable insight. The session has been truly enriching and thought provoking. I also thank all the participants for your active involvement and enthusiastic participation, which made the session meaningful and engaging. Thank you all and have a wonderful day ahead. Thank you.
Thank
The
you all
feedback,
participants. Tomorrow we'll meet again.
the feedback link is also shared. All the participants, please fill the feedback form. Thank you.